Now I'm given here the condition. I want to find the curve which is passing through this point. So when say point 2, 1, this same like as we say y at point 2 is equal to 1, or we say x equal to 2, y equal to 1. So we take here x equal to 2, and y is equal to 1. We substitute in equation 7, we get the value of c. So my c is equal to x equal to 2, that's equal to x squared is 4, or 1 plus 1 is equal to 4 plus 1 is equal to 5. So I can write my function solution as the x squared over y plus y is equal to 5 is a curve passing through the point, passing through point 2, 1. So I make a quick revision of the solution of this equation once again. We are having here given the differential equation of the curve having the slope. I want to find the curve, but I want to find the curve passing through the given point. I write in the differential form because in the standard form we having here mxy dx. This is my standard form. So I try to write in my standard form. We have dx, so I multiply here with dx, write here 2x dx. Then we take this one to other side. We have x squared minus y squared dy. But I keep this minus here, make it plus by taking this one inside. So it must be very clear that I am carrying this minus sign when we writing my n. So I write my mxy and write my nxy. So we check if this is exact or not. We take our test that differentiating this with respect to y, partially we get 2y. With respect to x, we're having minus 2x and the y is constant 0, but they are not equal. This means this differential equation is not exact. But we are asked to solve it one by the exact differential equation. So I go to find the integrating factor. To find the integrating factor, I told you that I will take this mxy. Why I am taking mxy? Because we having here product function 2xy, we can find the function of y only. But here when we take this one, we're not able to find the function of x, which as I did in the last example and showed you that one. So we start from m. To remember this formula, I told you, we get n first and then m for partial m by partial x, partial m partial y. We get 1 upon 2xy, get minus 2x, become minus 4x, cancelled. We get minus 2 by y, this is my gy. So now I get my integrated factor. My integrated factor formula is to find here f gxy, dy is equal to e to the power integral gy dy. My gy is minus 2 upon y. Integrate it, take minus 2 out. We get here ln of y. I have taken out that absolute because I know that we can just take this 2 as a power. So we get here ln of y to power 2, y to power minus 2, ln and en cancel 1 upon y2. We can just make here substitution because this is passing through the point 2 and 1. So y will be not equal to 0. We take particle. So otherwise, we can put here the condition x is not equal to 0, y is not equal to 0. And x is not equal to y also, because when x equal to y, this is becoming 0 and this must be out. So we have to keep that one because this is passing through this one. So don't need to put here the power. So we keep it like this one. I was here. So now we multiply our equation 1 with the integrating factor. So I get here 2xy dx minus, taking 1 upon y squared, this is 1 upon y squared is minus 1. Now this is my m, this is my n. Now I take the test partial m by partial y, partial m, partial x. They are equal. So as they are equal, so we say the equation is exact differential equation. If it's exact, then we can use here that we can write here partial f by partial x is equal to mxy and partial f partial y and xy. And we solve this number 3 and number 4 to get the solution fxy. So as I mentioned, we can start from here or we can start from here. We start from x and we integrate both the sides with respect to x. I get fxy, 2x over y into dx plus constant with respect to y. 2 and y are constant, therefore x is x squared by 2, 2 is constant 2, we get x squared by 2 plus gy. Now here what's left? We want to find gy, but we have not used number 6. We take the value of the partial y from equation 5 and substitute in number 4. So we're substituting here, getting the value with respect to y. Derivative of 1 upon y is minus 1 upon y square. Substituting it, we get minus, here we substitute the value, minus x square y square plus dg by dy is equal to minus x square y square plus 1. X square y square is cancelled with x square y square. Now they are cancelled and we get here gy is equal to 1 Integrating with respect to y, we get gy equal to y. We put the value of y here in number 5. So get here fxy is equal to x square y square, x square upon y plus y equal to c. This is my general solution. This is my general solution. Now we are given the question that we want to find the curve passing the point 2, 1. So we are interested in that one. So it's mean 2, 1 mean the point, the value of y at point x equal to 2 is equal to 1. I take x equal to 2 and y equal to 1. Substitute the value of x equal to y equal to 1 in equation 8. What we'll get? X equal to 2, we get here 4. 2 to the power 2 is 4, or 1 plus 1. 4 plus 1 is 5. Substitute the value of y number 8. We get x square upon y plus y equal to 5 is a curve passing through point 2. I will say is the particular solution. So I have just put my notes in the in Google Drive, and the link is given down in description. You can download these notes. We have more examples, and we have the exercise also. You can make the practice using example. Just take the question, try to solve yourself, and after that you compare the solution with my solution, and if it's not correct, then correct it and repeat it. So this way to learn it. Then number 1. Number 2, I would like that you just like this this video, also subscribe this one, and also press the button so that you can have ring button, that so you can have the notification for my videos, which I'm going to make it for you, and inshallah you will get the benefit of that one. So don't forget to download the notes. Notes are given there. More examples are there. I've just done 2 examples. Obviously, if we have time restricted, we can't take hour for this one to just clear this topic. The topic was to make exact by using integrating factor. We have the equation not exact because we have to solve by exact differential equation. We can solve this equation. We can solve by the homogeneous method also, but it's given that we have to use the exact differential equation, so we solve it like this.